A journey through time. Hello, science fans. Bill Nye here. Today we're going on an incredible adventure, a journey through time itself. But we won't need a time machine with flashy lights or spinning dials. Instead, our vehicle will be something you might be using right now. A computer, a phone, a tablet. We are going to explore the secret codes that make all our modern gadgets work. These codes are called programming languages. They are the instructions we give to computers to make them do amazing things. Playing games, helping scientists discover new galaxies. Programming languages are the building blocks of our digital world. So buckle up and get ready to explore how a few clever ideas changed everything. Think of a programming language like a recipe. If you want to bake a cake, you need a list of ingredients and a set of step-by-step instructions. A computer is like a very obedient but very literal chef. It can't guess what you want. You have to tell it exactly what to do in a language it understands. Over the years, we've gotten much better at writing these recipes. In the beginning, it was incredibly difficult, like trying to write a recipe using only the number 0 and the number 1. But with each new language, we made it easier and more powerful, allowing us to build bigger and better things with our computer chefs. Our journey will start in the early days of computing. Computers were giant machines that filled entire rooms. The first programmers had to flip switches and plug in cables just to get a simple calculation. Then we travel forward in time, meeting brilliant minds who invented new ways to talk to machines. Fortran, COBOL, BASIC. Each language was a breakthrough, a new tool that unlocked the potential of computers for more people, not just a handful of experts. As we move closer to the present day, September 6, 2025, we'll see how programming languages started to shape the world we live in. C++. These became foundations for operating systems and video games. Then came the explosion of the internet. Java, JavaScript, languages that brought websites to life. Finally, Python, a language so friendly it has invited millions to start coding. This is more than just a history lesson. It's the story of human ingenuity. Consider this. Let's set our time machine for the 1940s and 50s. Back then, computers were enormous, mysterious beasts. They didn't have screens or keyboards like we do today. To talk to them, you had to speak their most basic native tongue, machine language. This language wasn't made of words at all. It was made of numbers, specifically binary code, just ones and zeros. Imagine trying to tell your friend a story, but you can only use the words 1 and 0. It would be incredibly slow and confusing, right? That's what early programmers faced. A simple instruction like add two numbers might look like 00101 101110010010. It was powerful, but oh so difficult for humans to read and write. Every single type of computer had its own unique machine language. A program written for one machine wouldn't work on another. This was a huge problem. Programmers had to spend countless hours looking up long strings of numbers in giant manuals just to perform simple tasks. Making a mistake was easy, but finding it was a nightmare. A single 0 where a 1 should be could cause the entire program to fail. And finding that one tiny error in thousands of lines of binary code was like searching for a specific grain of sand on a beach. It took incredible patience and brainpower to get these early computers to do anything at all. To make things a little easier, brilliant people invented something called assembly language. This was a huge step up. Instead of writing long strings of ones and zeros, programmers could use short, memorable words called mnemonics. For example, instead of 00101101, they could just write ADD. Another program called an assembler would then translate these simple words back into the machine language the computer could understand. This made programming faster and much less prone to errors. Our time machine now jumps forward to the late 1950s. The world of computing was about to change forever. A team at IBM, led by a programmer named John Backus, was tired of writing in assembly language. They wanted to write instructions for the computer using familiar mathematical formulas. The result was Fortran, formula translation. Released in 1957, it became the first widely used high-level programming language. Programmers could write code that looked like algebra, x equals y plus z, and a special program called a compiler would translate it into machine code. It was a science and engineering game-changer. Scientists and engineers could now write complex programs without being hardware experts. They could focus on science, not ones and zeros. Fortran was built for number crunching. It helped design bridges, forecast the weather, and plan space missions for NASA. It performed calculations that would take humans lifetimes by hand. Fortran made computers a powerful tool for scientific discovery, and versions are still used today for heavy mathematical computation. It was a giant leap for computer kind. Meanwhile, businesses had a different need, processing huge amounts of data, customer records, payroll, inventory. In 1959, researchers from business and government created COBOL, with major contributions from Rear Admiral Grace Hopper. COBOL stands for Common Business-Oriented Language. Its goal was readability, even for non-programmers. Code looked like plain English. Subtract tax from gross pay giving net pay. COBOL became the backbone of business, used by banks, insurance companies, and governments to manage massive information systems. Every time you use a credit card or get a paycheck, a COBOL program might be running behind the scenes. Let's fast forward our journey to the 1960s, a time of great change. Computers were still mostly used by big companies and universities. They were expensive, complicated, and definitely not for everyday people. But two professors at Dartmouth College, John Kemeny Thomas Kurtz, had a revolutionary idea. They believed that everyone, not just scientists or business experts, should be able to use a computer. To make this happen, they needed a language that was simple, friendly, easy to learn. So, in 1964, they created BASIC, which stands for Beginner's All-Purpose Symbolic Instruction Code. And it was exactly that, a language for beginners. As we move into the 1970s, our journey takes us to Bell Labs. Dennis Ritchie worked there. He was building a new OS called Unix. An operating system manages all of a computer's hardware and software. To build it, he needed a powerful language. He wanted high-level ease like Fortran and low-level control like assembly. Around 1972, he created a language and called it C. It succeeded a language called BC was a beautiful balance. Efficient, fast, flexible. It gave direct access to memory for optimized code. It also had user-friendly features like functions and data structures to organize large systems. Dennis Ritchie and Ken Thompson rewrote Unix in C, a revolutionary idea. Before this, OCs were tied to specific hardware by assembly. Written in C, Unix became portable, a game changer. With a C compiler, you could adapt Unix source to different machines. It broke the chains to specific hardware. Our journey now arrives in the mid-1990s. The World Wide Web is exploding. At Sun Microsystems, James Gosling's team building a language for interactive set-top boxes. They called it Java. The TV project didn't take off, but the language fit the internet. Java's key promise was, write once, run anywhere. It could run on any device with a Java virtual machine, Windows PC, Mac, Linux computer. One version of an app could work for everyone. The result was JavaScript. Despite the name, JavaScript is completely different from Java. In the late 1980s, a Dutch programmer named Guido van Rossum was looking for a hobby project to keep him busy during the holidays. He wanted to create a language that was powerful, but also incredibly easy to read and write. He named it Python, not after the snake, but after the British comedy troupe Monty Python's Flying Circus, because he wanted programming to be fun. Python's core philosophy is all about simplicity and readability. The code is designed to look clean and uncluttered, almost like plain English. For many years, Python was a respected but niche language. However, in the 2000s and 2010s, it exploded in popularity. Why? One reason is its gentle learning curve. Because the syntax is so simple, beginners can start writing useful programs very quickly without getting bogged down in complex rules. So here we are, back in the present day. We've traveled from the era of ones and zeros to a world where we can write code that looks like English.